Okay, good morning. Welcome to
FamilyMath210.
FamilyMath21010, right? All right, so we've got, I saw an interesting article. I think it was another Steven Sorgat's post, actually. I'll have to check when I'm making the movie. And we saw that you can make these interesting shapes. Show your shape. That's two ellipses together. Show your shape.
And I've got two interlocking rings.
And then they had this shape, too, that you could make by putting two... I don't know how to describe these
They
shapes.
were circles with like circles taken out of them and the notch.
Yeah, and you put them together. And what we're going to do for our last movie is we're going to show how these roll. And it's pretty surprising that they roll, right?
Yeah, they don't look like they roll.
But what we're going to do for the first two movies is show how we used our 3D printer to make these shapes.
Yeah.
Okay, and we're going to specifically focus on these shapes. So, can you hold these for a second for me? So, we saw a shape. It's going to be tough for me to draw. You hold it up so I can see. So I kind of got a circle on the bottom, goes out like that, and then it has a notch. Okay?
Yeah.
So we saw that shape, and we needed to translate it over to our computer. So how did we do that? First, what was the geometry?
First, well, we had to make a circle, the big circle.
And then
We had to cut out these two quarter circles, one on each side.
Okay.
we
and then
had to
we-
make a notch.
No, first we had to cut out the bottom part of the circle because, like, there would be a little bit coming off if we didn't cut off it.
Okay.
And then we did the little slit.
All right. So we could understand the geometry. It wasn't too hard. We started with a big circle. Like that. And then we cut out, actually, you know what, let me draw it in the middle of the board. And I'll just sort of, instead of trying to draw four different pictures, I'll just draw them as we make them. We started with a big circle, but then it looked like these other two circles that we cut out came like this. Right? They went right to the halfway point of the circle, and then they met in the sort of middle part of the circle there. Right?
Yeah.
But then it goes to what you're saying. That notch doesn't seem to come all the way down from the top here.
So we have
So we had to slice out some part.
We sliced out some part like here just by cutting out a big rectangle. Even though a lot of this stuff was missing already.
yeah.
And then what did we do?
Then
And then we
we
made the notch.
drew the little slit.
We do a little notch like here so they could hook together.
Yep.
Show how they hook together? That's kind of nice. Okay, so now that we have the geometry behind us, we had to tell the computer to do this. And what do we need to be able to tell the computer how to do it?
Mathematica.
Mathematic.
Okay, we needed Mathematica. What
Yeah.
else?
Well, we had to know what we would have to know what the code would be.
Right, we have to know how to describe things like circles and really just rectangles for this. Now, this is a little bit advanced for what you've studied, but you and I talked about this last year. Do you remember what the equation of a circle is?
It's x squared plus y squared is the radius squared.
Okay, so we had x squared plus y squared is the radius squared. That's a circle with a center at 0, 0. Okay? And for the purposes of printing this, we just pretended the radius was 1. Next we had to figure out if the radius of all these circles that we were cutting out was 1, where would the center of one of these circles be? Let's do this one, for example.
Well, if we extended the graph a little bit,
Okay.
It would be at -1, 1.
We looked a little more at this grid and we saw that a quarter of the way around the circle it had a height 1,
Yep.
and a quarter of the way around the circle it had an x coordinate of -1. So that led us to believe the center would be here, -1, 1. Same exercise for this circle,
except there would be 1, 1.
except it would be 1, 1. And then came a slightly challenging thing of how do you tell a computer about a rectangle?
Well,
That wasn't so simple.
no.
What can we say about it, just a rectangle in general?
Well, you have sides x and y.
Okay.
And then there's 2 x's and 2 y's and then x and y. and then the two x's are equal, and the two y's are equal.
Right, that's true. So we have a shape that goes across in the x direction, we call this the x-axis, and we have a shape that goes up in the y direction, if we call that the y-axis. So how are we going to tell the computer? Draw this rectangle.
We can put in its x and y coordinates.
Ah, okay. What do we know about, say, the x coordinates of this rectangle?
Well, it's going to be, it's like at minus 0.5.
Well, we know the center of the rectangle.
Well, and we just made up any rectangle, actually. We don't, so we're not sure where its center is. It might be right here or something. But okay, so you said this was maybe minus 0.5?
Yeah, it looks sort of like the middle.
Okay, minus 0.5.
And then this would be 0.5.
Okay, so what does that tell us about x?
X is 1 because this is the length.
Oh, the distance across is 1. Yeah, but what do we know about the x values on this side of the rectangle?
Well, they're getting bigger.
Okay, they're getting bigger. What else?
And then they're going in a straight line.
They're going in a straight line. How can I tell? I can't tell the computer this kind of stuff. I need to tell the computer something very specific about them.
You can tell the computer where the start of it and where the end of it is.
Ah, great. I can tell where the start and where the end is. And why is that important?
Because then that's the coordinates of the rectangle.
Okay, in the x direction. What about in the y direction?
Well,
The y direction is just the up and down. So we can do the same thing.
Okay, so we do the same thing. We tell the computer where the x's start and where they end, where the y's start and where they end, and that gives us a rectangle. All right, so you ready to go over to the computer and take a look?
Yeah.
All right.